start the class. Okay. Hi guys, welcome to NEET WORLD Institute and NEET WORLD YouTube channel, and I hope you that you're doing well, right? So you know that we have started our IPE YouTube live session, right? So for both 11th and 12th students of Andhra and Telangana, right? So as we are doing this 11th and 12th alternative days, so the alternative days, whatever we are covering in the yesterday class should be revised in today's class, okay? And today will be, if we are doing yesterday 11th, today will be 12th, okay? So tomorrow 12th students should revise their questions and 11th class will be happening tomorrow, okay? So this will be our timetable, okay? So alternative days of classes will be either 11th and 12th will be there, okay? So this is the pattern we are using, and come to the point, like we have completed the topic, last topic, and we are going ahead of the topic, that is nucleus, okay, nuclei. So the first question of this, what is the radioactivity? State law of radioactive decay. Show that radioactive decay is exponential in nature. So they are given the question. In that question we need to see what are the subheadings has been given. Like we need to see how many parts of the question has been given. If we try to understand that, yes, it will be easy to analyze, and if we like, it will be easy to write down the answers. Okay. Yes, we will break down into steps. Okay. So first we need to start with what is radioactivity, right? And then we need to introduce what is the law of radioactive decay. Okay, introduce in the sense I am not going to do anything new thing, right? So whatever question they are asking, we are writing step by step, okay? And then show that radioactive decay is exponential in nature. So 3 parts has been given. Subtopic 1, 2, 3. So first one is radioactivity. Okay, yeah, 1 minute. Yeah, people are joining over here. Let's wait for 1 minute, okay? People are joining over here. We'll wait for 1 minute, and then we'll start with the answer part. Fine. So we'll start. Utkarsh, hello. This is radioactivity question, and this is from a nucleus lesson, okay? Class 12th topic. Like yesterday was class 11th IP classes, and today is 12th IP class. This is physics, okay? Nucleus. Okay, Utkarsh, is that fine? Okay, let's start with the answer, okay? So, radioactivity. The nuclei of a certain element disintegrate spontaneously by emitting alpha, beta, gamma rays. Okay, what is the meaning of that radioactivity means? Yeah, but sir, I am from class 10th. Utkarsh, no need to worry about that. Class 10. So whatever things you are studying, study it properly, and you can join our institute for class 11th and 12th, so we will train you properly. Okay. So nuclei certain element, the nuclei of certain element disintegrates spontaneously by emitting alpha, beta, gamma rays. This phenomena is called as natural radioactivity. Like the emission of gamma, alpha, beta, gamma rays, no, that is the thing they are saying as a natural radioactivity. Okay. To attain stability, certain heavy nucleus exhibit natural radioactivity. So to attain the stability, why they are doing that, we need to know that. To attain the stability of that. Okay. So nuclei of certain element disintegrates spontaneously by emitting alpha particle, beta particle, and gamma particle, like the rays. Okay. This phenomenon is called natural radioactivity. Okay. So to attain stability, they are emitting naturally. Okay. Now radioactive decay law. Okay, we need to explain what is the law of thing. So the rate of radioactive decay is directly proportional to number of nuclei present at that time. Listen carefully. The rate of radioactive decay, that is dN by dt. Okay, the rate of radioactive. The rate in the sense, obviously with respect to time only we should consider right now, is directly proportional to the number of nuclei. Okay, number of nuclei present at that time. Okay, so consider a radioactive sample, for example N. Okay, let the initial number of nuclei present is N naught. Initial number of nuclei present is N naught, and number of nuclei remains at that time t is N. Okay, so what happens here? What happens here? We are considering a radioactive sample. Right, radioactive sample in the sense the nucleus we should consider. Let initial number of nuclei present is N naught we have considered. At time t will be N. So minus dN by dt will be equal to lambda into N. So equation 1. Okay. Now what happens here? Where lambda is the proportional, like lambda is the proportionality constant called decay constant or disintegration constant. This lambda is there, no? It is decay constant or disintegration constant we are saying. So the negative sign indicates that decreases in number of nucleus with increase in time. So when time increases, nucleus decreases. Right? No? Decrease in number of nuclei with increase in time. So dN by N will be equals to, why we have taken like this, no? N we have taken, like with respect to N we are differentiating, no? Like here what we are doing is dN by N, no? With respect to N we are integrating. If we integrate that, now we will get the equation of that. Okay, so let me take a pen here, wait, let me explain you the thing properly. So what we are doing is, this equation is there, we have considered this equation by the law. Now what? N is there, dt is there, so minus dN by N, this N we have taken this side, will be equals to lambda into dt. So I can write this dN by N integral will be equals to lambda integral dt. Right. So this 1 by N is nothing but log N. How we are saying 1 by N is log N? Integration of 1 by x with respect to dx is log x. So what is the differentiation of log x? It is 1 by x. It is 1 by x. Right. So similarly, we are integrating 1 by N with respect to dn. Let me write that one properly. Okay. So that it will be clear for you. 1 by N into dn. Is it clear now? So 1 by x into dx, 1 by N into dx, so dn. Okay. So integrating some constant like dt we are integrating. So what we will get if we integrate something dx means we will get x. So similarly we will get t will get, right? No. So this is minus is there. Okay. Here minus. So this one will be log n will be equals to minus lambda and this t plus c. Whenever we are integrating, constant will be added up. Sorry sir, I am going because the class is not for me. That's class 11th, but I am class. Okay, no issues, so Utkarsh. You can prepare well for your examinations, class 10th, okay? the equation, right? Log n is equals to minus t, so minus lambda t plus c, right? So the next step what we should do, where c is the integration constant. So when t is equals to 0, t is equals to 0 in the sense what happens? N will be n naught, and hence log n naught will be equals to c. Yes, no? When t is equals to 0, t is equals to 0 means log n will be equals to c, right? Log n will be equals to c. So substitute the equation, simple. Log n will be equals to minus lambda t plus log n naught. So when I am taking this log this side, no, it will become minus, right? So when we are writing like this, log n minus log n naught, so the formula will be log of n by n naught, right? So will be equals to minus lambda t. So when I take this log this side, what happens? It will be exponent. So opposite of log is logarithm, exponent. Okay. So n by n naught will be equals to e power minus lambda t. So what will be the n value? N will be equals to n naught e power minus lambda t. Is that fine? Now we got the equation now. What we have done, when t is equals to 0, both the n and n naught will be same. What we have taken is initial some nucleus is n naught, after time t it becomes n, but when time t is equals to 0, both are equal. So log n naught will be c, constant will be n naught. So when we are substituting constant c as n naught, log n naught, and this log n naught we have taken this side, so it means log n minus log n naught, which means log n by n naught. So will be equals to minus lambda t. So n will be equals to n naught e power minus lambda t will be the equation. Okay. So this is the expression we have expressed. Now this expression represents the radioactive decay law. It shows that radioactive sample decreases exponentially with time. This constant lambda is characteristics of given sample. Okay, so this is how we will write the first question. So first thing what we need to do, radioactivity means what we need to write. Then we need to draw the diagram between radioactive nuclei with respect to time. So as it increases, it keeps on decreases, right? No? Yeah, radioactive decay law. Next one. So we have written the initial case as n naught. At time t, it becomes n. So we need to show that it's power of that, right? Exponent of that, and we have shown that. So n is equals to n naught e power minus lambda t. Okay, you can take a note of this. Go for the next question. Second question. Done. Okay. So the next question is, explain the principle and working of a nuclear reactor with help of label diagram. So I need to explain the nuclear reactor with the label diagram. So what will be the diagram? I'll show you the diagram first. Okay. So these are the diagram, like what are the things present is like control rod will be there, then coolant will be there, uranium will be there, then moderator that is made up of graphite, then reactor, okay, then pressure vessels will be there. Okay, so like a simple diagram we should write, and we should mention the terms. What are the terms is control rods, then graphite, like a moderator, okay, the total thing will be reactor. Okay, the total thing will be a reactor. Under, like inside reactor, control rod will be there, then a moderator will be there, then pressure vessel will be there. Okay, So coolant and uranium, like in between a moderator, uranium will be there, like in between graphites, uranium will be there. Okay, so coolant will be there, coolant has been taken here. So steam is coming out and water we should insert. Okay, so coolant, circulating pump. Okay, these are the things we need to mention when we are drawing the diagram. No need to draw the diagram exactly, like a proper diagram will be there. We should mention the things properly. Okay, that will be good enough, right? So no one is good in drawing. Like, yeah, I am not good in drawing. Like people, like you guys will be too good in drawings, right? Yeah, you can draw well. Okay, you can practice 1 or 2 times. It will be perfect to draw in the examination. So explain the principle and working of the nuclear reactor. Now, what is the principle? A nuclear reactor is device that works on a principle of controlled chain reaction. Controlled chain reaction. It is also called as atomic pile. Atomic pile. Okay, that's the first point. So the figure shows that the schematic diagram of nuclear reactor. The core of the nuclear reactor is placed where the nuclear fission takes place. Right now, once you can see the diagram now. So we have started the principle and you can see the diagram now. Okay, you can take down the diagram. So you have taken the diagram, right? Okay, now you can see here. So the second point, what they are saying, the figure shows the schematic diagram of a nuclear reactor. Yes, it's a nuclear reactor diagram. The core of the nuclear reactor is a place where nuclear fission process takes place. So inside that, whatever we have mentioned, so the process will be takes place inside, like nuclear fission process. Okay. So now, essential component of the nuclear reactor. What the first one is fuel. Now we are explaining the what are the things we have like mentioned in the diagram. Okay, first one, fuel. So the fissionable material used in the reactor is called nuclear fuel. Okay, it is taken in the form of rod and sealed in aluminum cylinder. So example, enriched uranium U power 235 or enriched plutonium Pu power 239. Okay. Excuse me. Next is moderator, control rod, shielding, okay, and then coolant. So like the main thing we should explain what are the things are there. Okay, so second one is moderator, a substance that slow down the fast moving neutrons produced during fission. Average energy of neutron released is 2 megavolt. Okay, they are slowed down to the thermal neutron, that is to 0.025 electrovolt. So example, heavy water, graphite, hydrocarbon, plastics. So these first 2 points you can take down. Next we'll see the next 3 points. Okay. Done? Okay. So the next one, control rods. The fission rate in reactor is controlled by using neutron observing material. Example, cadmium, boron. Okay, cadmium, boron, example. So whenever we are explaining something, we should say with some example. Then it will be more a professional way to say the things, right? No? Okay. So next is shielding. During fission, beta and gamma radiation are emitted along with neutrons. So proper shielding is used to absorb and reduce the radiation intensity. So like steel, lead, concentrate, concrete, sir. Like lead in the sense like graphite, sir. Right? No? Okay. So next is coolant. The heat generated in fuel elements is removed by using a suitable coolant. So the coolant flow around the reactor under high pressure. Example like water, heavy water, or molten sodium. Okay. So you can take a note of this. Control rod and shielding. Done. Okay. So the next is coolant. Okay, we can take a note of this, and we'll go for the next question. Yeah, one more part we will see. Okay, how it is working also. Okay. Yeah. Done. So the working we'll see here. So uranium fuel rod placed in aluminum cylinder, separated by graphite moderator. Okay, first point. Second point is neutron released from uranium fission passes through graphite moderator and become thermal neutrons. What happens? Neutrons released from uranium fission passes through graphite moderator and becomes thermal neutrons. Okay, these thermal neutrons initiate further fission. Okay, this thermal neutron initiate further fission, sustaining the chain reaction. Fine. So control rods are adjusted to maintain the required fission rate. So the heat generator is heat generator is transferred to coolant. Then what happens? The coolant transfer heat to water and converting into steam. Obviously, when heat is produced, to control the heat, we are sending the water. That will convert them into a steam. The steam drives a turbine which runs a generator to produce electricity. Okay, so these are the working principle of that. Done? Okay, the next question. So explain the source of stellar energy, explain the carbon-nitrogen cycle and proton-proton cycle occurring in the star. Okay, obviously when we are talking about the stellar energy, like it's about stars we are talking. Yes, no, stars. So sun is also a star, no? Yes. The energy of a sun and the brightest star is produced by nuclear fusion called stellar energy. Understood now? When the topic stellar, like somewhere we have heard in the lower classes, the stellar energy, right? No? Yes. So the energy of a sun and the brightest star is produced by nuclear fusion. So which is called as stellar energy. Okay. So the question first they are asking what is the stellar energy. We have explained the question. Now second part of that is explain the carbon-nitrogen cycle and the proton-proton cycle occurring in the star. Okay. Now let us see here. The sun and star radiates energy due to fusion reaction in their core, where temperature is around 10 power 7 Kelvin. 10 power 7 Kelvin. Okay, it's not even like it's more than what we are expecting. No, 10 power 7 Kelvin. Right. So now carbon-nitrogen cycle, CN cycle we'll say. According to like Beth Weizsäckers, the CN cycle is a chain of nuclear reaction in which a proton combines to form helium. Okay, helium with carbon and nitrogen as a catalyst. So when we see the reaction, no, H plus C gives N plus gamma, right? And N gives C plus electron plus neutrino. This is neutrino. Okay, this N is given as C plus E power plus. E plus in the sense electron or proton, it's a proton, right? No, E negative in the sense it's electron. So proton plus neutrino. So next one is C plus H gives H plus gamma. Obviously H plus C gives N plus gamma. C plus H also N plus gamma, right? No. So O gives that N plus proton plus neutrino. N plus H, which is nothing but C plus helium, Hg, right? So the net reaction, like these are the reactions are happening. The net reaction will be 4H will be given as helium plus 3 gamma plus 2 proton plus 2 neutrino. So this is the reaction takes place. So energy release will be 26.7 megavolt. Okay. So this cycle operates in star with core temperature around 2 into 10 power 7 Kelvin. Okay. You can take down the reactions whatever is happening here. Okay. And then we'll go for the next one. Done? Okay. Next one, it's a proton-proton cycle, PP cycle we will say. Okay? Done? Okay. So the proton-proton cycle represents fusion reaction where hydrogen is burned into helium. So hydrogen plus hydrogen gives hydrogen plus electron plus neutrino, and hydrogen plus hydrogen gives helium plus gamma. Right? So these are the two reactions. So the net reaction also which is there, these two reactions occurs twice to yield. Like twice to yield that. Okay. So what is that? Helium plus helium gives helium plus 2 hydrogen. Right? So now the net reaction will be 4 hydrogen gives helium plus 2 proton plus 2 neutrino plus 2 gamma. Okay, this is the net reaction of the proton-proton cycle. You can take a note of this. Done? Okay. So the next one is like energy release is 26.7 megavolt. So this cycle occurs in stars like Sun called red dwarf. So where hydrogen fusion is the main energy source. Right? Hydrogen fuse, like because of that only the Sun gives the brightest light. Right? No? Okay. So once we will revise whatever we have seen here. So the first question is what is radioactivity? So state the law of radioactive decay and show that the radioactive decay is exponential in nature. So first what we need to explain, what is the meaning of radioactivity. Next I need to explain the law of radioactive decay, and we need to show that its decay is exponential in nature. So when we are writing the law itself, we will come to know that by the equations. Yes, it is n is equals to n naught e power minus lambda t. So in exponential in nature. Right. So the next one is explain the principle and working of nuclear reactor with help of a labeled diagram. So we need to first mention whatever the terms present in the nuclear reactor, right? A coolant, water, steam, everything. Okay. And what is the graphite rod? Everything we should mention. Right now. And principle and working, I need to write it. Like what is the principle first? Yes, I need to write it. Next, essential components, whatever it is there, I should mention. And I need to say some components why they are used there. Okay. Next, I need to say the working of that. Okay. This is about the second question. And the third question is Yes, it's a stellar energy means what? And then I need to explain carbon nitrogen cycle and proton proton cycle. Okay, so with this today's 12th topic has been completed, that is nuclei, LAQ, that is long answer questions. Okay, so we will see the short answer questions in the upcoming classes. Okay, so we will meet in the next class, guys. Bye bye, take care, and don't forget to revise these questions. Okay, whatever questions we have done, no, everything try to revise it. Okay, so it will be easy to cope up with the classes. So if you keep on postponing that one, no, it will become hectic. Right now I need to study this or this, you don't understand, like the tension will begin, exam fear will become. For that we should avoid that. We need to maintain proper timetable, proper structure of that. Right? Okay guys, we'll meet in the next class. Take care. Bye bye.